Good morning, students. In the previous video session, you have gone through the vehicle on a leveled circular road and about the banging of truck. And today we can see about the centrifugal force. And already we have discussed about the centripetal force, and we have learned how the centripetal force is arising from different forces. And today we can see that what is this centrifugal force? Centrifugal force. Actually, we know that centrifugal force. So if you are saying about this centrifugal force, actually this centrifugal force we can tell it is a pseudo force, or you can tell that it is a fictitious force. So what is this pseudo force and what is this fictitious force means? Actually it is not a force, and we can tell that it arises due to the inertial nature of the frame what we are considering. If you are saying that we can tell that it is a pseudo force, and pseudo force or fictitious force means what you can tell means it is just not a real force. It is not a real force. It is some imaginary force. That is what the meaning of pseudo force. And centrifugal, we can tell the meaning flee from center. Centrifugal meaning is flee from central. So this centrifugal meaning we can tell flee from center. And this centrifugal meaning we can tell flee from center, and this is just opposite to the centripetal force. We know that the centripetal force is acting inward direction. If a moving object, if an object is moving in circular motion, so from here inward force, there is an inward force towards the center only. We are saying this is centripetal force, and the centrifugal force means there is a force which is acting outward to balance this centripetal force. So that is what centrifugal force. We can tell that it is an outward force which is acting in equal and opposite force, or about it is an equal and opposite force against this centripetal force, we can tell. So if you are taking the whirling motion of a stone, you can see that here the whirling motion of a stone. This is what we can tell, the whirling motion of a stone. You all have the practice of playing this, no? Tying an object, tying a stone on a rope and rotating like this. So due to this whirling motion of a stone, what you can tell is, assume that this stone, you can see here, so this is what assume that one stone is tied in a rope. This is what the stone is tied in a rope, and rotating. While rotating, it is moving in a circular motion, and this motion only we are saying whirling motion of a stone. So this direction centripetal force is acting, and assume that the stone which is has an angular velocity omega. So assume that one whirling motion of a, here we are considering a whirling motion of this stone, and assume that the stone angular velocity is omega. It has some velocity omega in the inertial frame. Inertial frame means at rest. Assume that it is at rest. The thing is, if we are rotating this, during this rotation time, if we are observing the motion of the stone, we can see that this stone is at rest. we will feel that the stone is at rest, it is not moving. That is what while rotating times we can see that. So if you are observing the motion of the stone in a rotating frame, what will happen means, what you can see means, the stone is moving with the same angular velocity omega, but the stone appears to be rested. We can feel that, we can see that the stone is at rest, it is not moving. Actually, why this is happening? Why it is appearing that the stone is at rest? We know that when we are rotating this stone, what happened means there is a centripetal force which is acting inward. That centripetal force is what? Minus m omega square r. Or you can tell that there is an inward force is acting. That inward force is what we are saying, centripetal force minus m omega square r. So if there is a force which is acting towards the center, there must be a force which is acting outside also, which is equal and opposite direction. So that plus m omega square r is acting outward direction. So if you are taking the total force of the stone minus m omega square plus m omega square r equal to, we will get 0. That's what we can see. We can feel the stone is at rest. The stone is at rest, and this outward force plus m omega square r, this outward force only we are saying centrifugal force. Centrifugal force. I'll tell more about the centrifugal force. Now this is a long answer question. Long answer question number 7. You have to write about the centrifugal force. The question is like this. Long answer question number 7 is, briefly explain the centrifugal force with some example. Example I will tell you. So this is what here I am taking this whirling motion of a stone example only I am taking. So what thing you can write means, you can consider the case of a whirling motion of the stone, and the stone is tied on a string. Assume that when the stone is rotating time, what will happen? If this stone is moving with an angular velocity omega, but we are observing, if the motion of the stone we are observing, what we can see means this stone is moving with the same angular velocity omega only, but what we can see, it appears what the stone is at rest. Why it is happening? Why the stone is at rest we are seeing? Why it is happening? That's what we know, that when we are turning this stone, what happened means there is an inward force. Inward force is acting, minus m omega square is acting inward. So if there is an inward force minus m omega square r, there must be an equal and opposite force which is acting outward from the stone. Outward from the stone. So here there is acting minus m omega square r, centripetal force inward means the same equal but in opposite. Here minus means here plus, equal force m omega square is r is acting outward direction. So if you are taking the total force acting on the stone minus m omega square r plus m omega square r, we will get to 0. And now you see we got this 0, because so that we can see the stone is at rest, and this outward force plus m omega square r only we are saying centrifugal force. Okay, and if you are saying the example, Assume that you are traveling in a car or something. When you are traveling in the car, sometimes suddenly the car driver turns the car in a corner. Maybe he has seen a covered road suddenly, so suddenly he is standing that car. That time we know that those who are sitting inside, we are feeling an outward force. We are feeling an outward force. You know that your head and your body part will move outward direction. This outward force only we are saying centrifugal force. Also, you know that we have the experience of traveling in the bus and all. When they are moving very fast with a high speed, suddenly they will turn the covered road and all. We can see that our body will push outward direction. This is because of the centrifugal force. Actually, the centrifugal force, it is a pseudo force or it is a fictitious force. It is an imaginary force only. But you see, the effect of this force is very hard. The effect of this force is very hard. We know that once our body is pushing outside, maybe if the door and all opened means we will meet with an accident and we will die. But it is an imaginary force. It is called a centrifugal force. Also, we know that some person which is traveling, this is what they are saying in the bus and all, government bus and all. It is written, don't travel by standing in the step of a bus. So it is very important. You never do this mistake. If you are traveling in the step of a bus, what will happen means, when the driver turns this bus suddenly in a covered road, what will happen? Those who are standing in a step, they will feel an outward force, so they will be pushed outward direction, so they can they will be met with an accident. This is because of the centrifugal force. Also, you know that when you are in the childhood and all, two kids will hold their hand and they will stand and rotate. While they rotate, they are experiencing an outward force on their body. So this is also centrifugal force. Or you can tell that, assume that there is a rotating frame like this. Assume that there is a rotating frame like this. Assume that this is rotating very fast, so you are standing here. So if you are rotating, you will feel a outward force. So that force, what we can say is m omega square by r. M omega square r plus m omega square r. Like that, it is saying about the centrifugal force due to the rotation of the earth also. We know that the earth is rotating. So if any object on the surface of the earth, they are experiencing a centrifugal force. So what happened means, this centrifugal force is acting in the opposite direction of axis of rotation. And here you can see the example. You see, rotating platform. If you are standing at this and we feel an outward force like this. So this is what centrifugal force. So for this, like this many example, it is given in the textbook. Also, it is saying about the free body diagram. That and all in the next part we will discuss. So this is one of the very important 5-mark question in this unit. So in the every exam we can expect this 5-mark question. It is a long answer question number 6. Explain the similarities and differences of centripetal and centrifugal force. So it is one of the very important question. So all of you must study this question. It is a very simple question, but it is a very important question. The first thing is about the centripetal force. It is a real force which is exerted on the body by the external agencies like gravitational force, tension in the string, normal force, etc. But centrifugal force, it is a pseudo force or fictitious force which cannot be erased from gravitational force, tension force and normal force. But a student, I said that while teaching the centripetal force, the centripetal force is arising from gravitational force. Centripetal force is arising from tension in the string. Centripetal force is arising from the normal force. Centripetal force is arising from the Coulomb force. Centripetal force is arising from frictional force. Like that I said many things. So the centripetal force, it is a real force. It is a real force, but it is arising from what? Some of the external agencies, some other forces like gravitational force, like tension in the string, and the normal force. But centrifugal force, it is a pseudo force or fictitious force. It is an imaginary force. It is an imaginary force, and it is not arising from gravitational force or tension force or normal force like the centripetal force. And the second point is, it acts in both inertial and non-inertial frame. So both inertial frame and non-inertial frame, the centripetal force is acting, but the centrifugal force acting only in the rotating frame. So, or you can tell that a non-inertial frame. But the centripetal force, it is a real force, so that in both inertial frame, object at rest, and non-inertial frame, what are both inertial frame and non-inertial frame, it is acting, but this centrifugal force is acting only in non-inertial frame, which is called rotating frame. That is what the second point. So the third point is, it acts towards the axis of rotation or center of the circle. That is what I said. This is the center of the circle. Centripetal force is acting like this towards the center of the circle, but centrifugal force is acting outward the circle. This is what centrifugal force, this is centripetal force. So centripetal force is always acting towards the center. So here also you see centripetal axis. From this stone, centripetal force is acting towards the center of the circle or the axis of rotation, and the centrifugal force is which is acting outward force. So that is what the next point. It acts towards the axis of rotation or center of circle in the circular motion. It acts what? Outwards from the axis of rotation, or radially outwards from the center of the circular motion. And the formula both are same, mv square by r, mv square by r. And next point is, centripetal force is real force and has a real effect. And origin of centripetal force is, real force and has real effect. Here it is a pseudo force, but it has a real effect. So if we are taking about the centripetal force, it is a real force. You see, when this stone is rotating during this whirling motion of a stone, there is a force which is acting inward. That's what this object is moving in circular motion. So it has a real, it is a real force, that it has real effect. Because of this centripetal force only it is moving circular motion. It has a real effect. But centrifugal force, it is an imaginary force. It is a pseudo force. But you see, effect is large. I said that those who are traveling in the platform of bus, when you are traveling in the bus platform or step, when they stand in a curve, suddenly the passenger who is standing nearby the step, they will be thrown outside due to this centrifugal force. You see the real effect. But this force is what? A pseudo force, an imaginary force. But the effect will be more. And the next one is, the origin of centripetal force is interaction between two objects. Origin of centrifugal force is inertia. It does not arise from interaction. You see, the origin of centripetal force is interaction between two objects. I said that when a car is moving, there is an interaction between the tire and the road. Due to this interaction, frictional force is produced. and this frictional force is providing centripetal force to turn the curved rod. But here the origin of centrifugal force is inertia. You see, we know that the inability of changing your state. You see, you are traveling in a bus. I said that if we are standing in rest, suddenly our body is changing to motion, but that inability of changing our state from rest to changing the direction only, it is a problem. That is what origin of, so that there is a force is producing centrifugal force. So this origin is due to the inertia, it does not arising from interaction. And the last point is, in inertial frame, centripetal force has to be included when free body diagram are drawn. So when you are drawing the free body diagram, you have to include this centripetal force also in inertial frame. You can see that here, you see, this object is moving in circular object. Here I am drawing the inertial frame diagram. You see, this is what in the inertial frame, observer is standing in outside. You can see the difference. Here I am standing, assume that this is your teacher Lenin. So Lenin sir, here Lenin sir is standing outside this object. Now it is what he is observing in inertial frame. Now you can consider only centripetal force. You see, centripetal force is acting inward, normal force acting upward, downward force mg. But at the same person standing with this rotating frame, now he is observing in rotating frame. Now you have to include this centrifugal force also in the free body diagram. So now in the rotating frame or in the non-inertial frame, you have to draw the free body diagram. You have to include the centrifugal force also in the free body diagram. But in the inertial frame, only centripetal force is included. That is what the last point. In the inertial frame, centripetal force has to be included when free body diagrams are drawn. But you see, in an inertial frame, the object inertial frame appears centrifugal force in the rotating frame. That is what when you are standing outside and look, you can feel that the centrifugal force is in the rotating frame. But in the inertial frame, there is no centrifugal force. But in the rotating frame, you see both the centripetal and the centrifugal force has to be included when free body diagrams are drawn. That's what I shown here. I am standing here. Now I am observing in an inertial frame. So when I am observing, I will feel that the centrifugal force is in the rotating frame. But in inertial frame, there is no centrifugal force. But in the rotating frame, now I am in the rotating frame. So in non-inertial frame, both the centripetal force, centrifugal force, I am included in the free body diagram. Here only centripetal force is included in the free body diagram. So my dear students, this is your long answer. Question number 6. Explain the similarities and differences of centripetal and centrifugal force. And this is what your assignment, the first assignment of this week. This question you have to write in your assignment notebook. This is one of the very important question. Also you have to write this banging on track. Last class video I have taken banging on track. This is also on your assignment notebook. So this week assignment is banging of track and this one, centripetal force and centrifugal force. So thank you all. Bye bye. See you.